This week we are going to study standing waves. Let's watch a demonstration first.
Standing waves are a result of reflection and interference. As I send a single pulse down to this fixed end, you can see that it reflects upside down on itself. If I send a rhythmic pulse, it reflects on itself. This is the fundamental mode. Sending the pulse at twice the frequency
Now, from now on, what's happening is I'm going to ask you to focus observing those points, the points on the hands, also the middle points there, on this string.
results in the second harmonic. If I triple the frequency, I get the third harmonic.
Now, what can we say about those points are? If you say those points, the particle on this point, on those points, they doesn't move. No matter how does the string moving up and down on oscillating frequency, the particles on these 2 points, they don't move. So we call them the nodal points. Okay. Now, let's watch all this again.
Upside down on itself. If I send a rhythmic pulse, it reflects on itself. This is the fundamental mode. Sending the pulse at twice the frequency.
Say, if you say those are nodal points. However, we call those points when they have highest vibration, which will be there and there, we call those points antinodal. So make sure you know that.
Results in the second harmonic. If I triple the frequency, I get the third harmonic.
Okay. So if you go to your notes, page 8.3, you'll see this. So we have nodal points at the end and antinodal points there. That's what does they mean. Yep. Sometimes we also call them resonance. Well, resonance is only for sound. It's basically standing wave for sound. What we're using as a demonstration before was a string. But let's talk about standing waves in strings first, then we go on to the sound. So, yep. Now, the important thing about this scenario with standing wave is now, the point A and B are fixed. Okay, this is a very important point. If points A and B are not fixed, we won't be able to have any standing waves. The wave will just pass through, and it won't reflect back, so causing a rapid going up and down of the string. So in this case, make a note. We are going to study the standing waves of both ends at fixed. Okay. So when we have in the video, they talked about harmonics. Also, you find it in your notes, page 8.7. So, but let me just show you what does exactly what they mean. Assume we have points A and B at fixed position, also with a string in the middle. Now, what we can do is the string actually can have a standing wave like this. We call this the fundamental standing wave. Okay, and it also can have a standing wave like this. okay, with with one more nodal line in the middle. Also, okay, it's possible to have something like this, okay, with two nodal points in the middle. Okay. So, okay, so we call those different wave, okay, different scenario harmonics. Okay. Initially, we have the fundamental harmonic. We call them all the first harmonic. Then we have the second harmonic. Then we have the third harmonic. Okay. So just be careful with the names. Okay. This one can be called the fundamental. Well, let's start with harmonics. This one, the first one, can be called the first harmonic. Okay. Here will be the second harmonic. And the last one will be the third harmonic. Etc. So on. It can go further on. Now, we can call this the fundamental frequency, because this is the fundamental frequency. Okay. Or for this one, we can call it the first overtone. Okay. So similarly, we call the third harmonic second overtone. Okay. So because the reason is a lot of students get those numbers confused. Just remember, if you're talking about harmonic, we have first, second, and third. Okay. So if we're talking about fundamental frequency, then the first first overtone will be the second harmonic. Okay. Just in the end of year final exam, when they're talking, especially in multiple choice questions, when they're naming those standing waves in different names, sometimes students get confused. Now, let me show you more demonstration about those standing waves. Okay. So let's talk about it later. So the idea that changes the harmonic is they use different frequencies. Okay, when they use different frequencies, different harmonics comes up. So, when they use low frequencies, we have lower harmonics. When we use high frequencies, the standing wave behave like a high harmonic. Okay. Now, so in next video, okay, we are going to talk about calculations about harmonics.